ng Diyos. Maraming salamat po sa buhay at lakas na aming taglay, sa liwanag ng kaisipan at sa pagkakataon maipagpatuloy ang pag-aaral ng mga kabataan. Gabayan mo po ang bawat isa sa amin. Anuman ang bahagi na aming gagampanan, naway maging maayos at matagumpay ang pagtuturo at pag-aaral na aming gagawin sa araw na ito. Patawarin mo po kami sa aming mga pagkulang at pagkakasala. At sa aming paggawa, ikaw po ang aming makasama. Amen.
Ang bayan ko'y tanging ikaw, Pilipinas kong mahal, ang puso ko at buhay man sa iyo'y ibibigay. Tungkulin kong gagampanan na lagi kang paglingkuran, ang laya mo'y papantayan, Pilipinas kong hirang. Ang bayan ko'y tanging ikaw, Pilipinas kong mahal, ang puso ko at buhay man sa iyo'y ibibigay. Tungkulin kong gagampanan na lagi kang paglingkuran, ang laya mo'y babantayan, Pilipinas kong hirang. Ang laya mo'y babantayan, Pilipinas kong hirang.
Great morning, senior high school students of Valenzuela City. Welcome to Valenzuela Live Facebook live streaming classes in General Mathematics. I am glad to be with you again. Come and join me in today's session as we learn the key concepts of propositional logic. Are you ready? Let's start! At the end of this session, you are expected to meet our today's objectives, which are illustrates and symbolizes propositions. Number 2, distinguishes between simple and compound propositions. And lastly, number 3, performs the different types of operations on propositions. Let us start today's lesson by recalling the 4 sentence functions in English. These are declarative, exclamatory, interrogative, and imperative. Number 1, declarative sentence states an idea. Number 2, exclamatory. Exclamatory sentences shows strong emotions. Number 3, interrogative sentences ask question. Number 4, imperative sentences give orders or directions and so end with period or exclamation mark. I think you're ready to answer the first activity entitled Identify Me. Use the comment box below for your answers. Comment heart sign if your answer is declarative, hair sign if your answer is imperative, and wow sign if your answer is exclamatory. I'll be giving you 5 seconds to key your answers on the comment box. Let's start. Okay, number 1. Mindanao is an island in the Philippines. I'll be giving you 5 seconds. Go! If your answer is heart sign, and you are correct because this declarative sentence and Mindanao is an island in the Philippines. Question number 2. Find the number which divides your age. 5 seconds. Go! Time's up. If your answer is hair sign, then you are correct because this is an example of imperative sentence, since the sentence gives an order to find the number which divides your age. Question number 3. My seatmate will get a perfect score in logic exam. 5 seconds. Go! Time's up. If your answer is a heart sign, then you are correct. The sentence is declarative, but its truth value will only be known after the logic exam. Nonetheless, it can either be true or false, but not both. This concept is actually the definition of propositions. Proposition is a declarative sentence that is either true or false, but not both. Let's have another activity to enlighten us about proposition. You're going to use again the comment box below to key your answers. Use hair sign if it's proposition and sad sign if it's not proposition. Are you ready? Let's start. Number 1. The Earth is farther from the Sun than Venus. 5 seconds. Go! Time's up. If your answer is a care sign, then you are correct because P is a proposition since the statement is declarative and the truth value is true. Let's have number 2. Number 2, the statement is, look out! 5 seconds. Go! Time's up. If your answer is a sod sign, then you are correct because Q is not a proposition since the statement gives a caution or reminder. Question number 3. Proposition R, x plus 2 is equal to 2x. 5 seconds. Go! Time's up. If your answer is a sad sign, then you are correct. We cannot identify its truth value since the statement does not have specific value for x. Question number 4. Clean up your room. 5 seconds. Go! Time's up. Sentence number 4 is not a proposition since the sentence gives a command. Last number, question number 5. X plus 2 is equal to 2x when x is equal to negative 2. 5 seconds. Go! Time's up. If your answer is a care sign, then you are correct since we can identify the truth value of the given equation. The truth value in proposition is very vital. Since we are talking about truth value, in proposition, we will encounter also a truth table. The question is, what is a truth table? A table that gives the truth values of a compound sentence formed from a compound sentences by means of logical connectives as and, not, or for every possible combinations of truth values of the component sentences. Let's say in example number 3, since a proposition has two possible truth values, the seatmate will get a perfect score or the seatmate will not get a perfect score. A proposition P would have the following truth value. P will be true or false. Truth table can also be used to display various combinations of the truth values of two propositionals, P and Q. The rows of the table will correspond to each truth value combinations of P and Q. There will be 2 raised to 2 is equal to 4 rows. Similarly, suppose P, Q, and R are propositions, then the truth table involving the given propositions has 2 raised to 3 is equal to 8 rows, as shown in the table. In general, a truth table involving n propositions has 2 raised to n rows, wherein n is the number of propositions. Grade 11 students, can you still follow? Okay, just like in other mathematics topic, proposition also have its own logical operators. The first logical operator is negation. The negation is a proposition P is denoted by this symbol or not P and is defined through its truth table, wherein proposition P has 2 truth values which are true and false. If we're going to negate P, the truth value will be false and true. Let's have an example. This movie is interesting. You're going to negate P, which are, number 1, this movie is not interesting. And it can be written, number 2, this movie is uninteresting. And lastly, you can rewrite in this symbol, it is not in the case that this movie is interesting. Can you still follow? Let's have another example. State the negation of the following proposition. Number 1, proposition N1, wherein P of x is equal to x minus 1 over x plus 2 is a polynomial function. I'll be giving you 10 seconds to key your answer in our comment box. Okay, time's up. So the correct answer will be the negation of N1 or N sub 1 is it is not true that P of x is equal to x minus 1 over x plus 2 is a polynomial function, or simply P of x is equal to x minus 1 over x plus 2 is not a polynomial function. Next, let's have number 2. N of 2, wherein the tinikling is the most difficult dense. Grade 11 students, I'll be giving you 10 seconds again. Go! Okay, time's up. So, the correct answer will be the negation of N2 will be the tinikling is not the most difficult dense. The next one will be the logical operators for 2 propositions. Binary operators, which are conjunction, disjunction, conditional, and biconditional. First one will be conjunction operator. Conjunction operator is a binary operator which, when applied to 2 propositions P and Q, yields a proposition P and Q denoted by this symbol. The conjunction P and Q is proposition that is true when both P and Q are true and false otherwise. Let's have an example. Proposition P is, this book is interesting. Proposition Q states that I am studying or staying at home. So the conjunction of P and Q will be, this book is interesting and I am staying at home. So let's proceed to the truth table. Using the truth table, so we have two propositions wherein 2 raised to 2 will be equivalent to 4 rows. So in proposition P has 4 truth value, which are true, true, false, and false. In the proposition Q has also 4 truth value, which are true, false, true, and false. To identify the conjunction of P and Q, using the definition which is, they are true, or the proposition P and Q under conjunction operation is true when both P and Q are true, and otherwise they are false. As you can see, in the first row, wherein P is true and Q is true, therefore the conjunction of P and Q is true. The others will be false. For us to enlighten further about conjunction, let's proceed to another example. Let P and Q be the propositions. P consists of angels exist. Q proposition will be pi is greater than 3. We are going to express the following conjunction in English sentences or in symbol as the case may be. Number 1, the conjunction of P and Q. Number 2, angels do not exist and pi is greater than 3. So let's reveal the solution. In number 1, the conjunction of P and Q is equal to the English sentence, which is angels exist and pi is greater than 3. While in number 2, the English sentence is angels do not exist and pi is greater than 3. This is equivalent to this symbol. It is the conjunction of the negation of P and the negation of Q. Can you still follow, grade 11 students? So let's proceed to the next binary operator, which is disjunction operator. The disjunction of two propositions P and Q is denoted by this symbol, or like V, or simply P or Q, and it is defined through its truth table below. The truth table shows that the disjunction of P and Q is false only when both disjunction P and Q are false. As you can see on the bottom of the table. Let's proceed to the example. Proposition P consists of, this book is interesting. Proposition Q states that I am staying at home. The disjunction or the disjunction of P and Q is, this book is interesting or I am staying at home. For the truth table, again, the truth table shows that the disjunction of P and Q is false when both P and Q are false. Otherwise, they are all true. Let's have an example. Let P, Q, and R be the following propositions. Proposition P states that Paul has a date with Esther. Proposition Q, Jacob is sleeping. Proposition R, Peter is eating. Express the following disjunctions in English sentences or in symbols as the case may be. Number 1, the disjunction of Q and the negation of R. Number 2, either Paul has a date with Esther, or Jacob is sleeping, or Peter is eating. Okay, for the solution, number 1, the disjunction of Q and the negation of R will be either Jacob is sleeping or Peter is not eating. Number 2, the English sentence either Paul has a date with Esther or Jacob is sleeping or Peter is eating can be written in the form of the disjunctions of P, Q, and R. Can you still follow? So let's proceed to conditional proposition. Conditional proposition of P and Q is denoted by this symbol, P arrow to Q, or simply if P then Q, and is defined through its truth table. So let's proceed to the truth table. The conditional PQ may also read as P implies Q. The proposition P is called the hypothesis, while the proposition Q is called the conclusion. Again, using the truth table, it is false when P is true and Q is false. And it is true otherwise. As you can see on the second row, wherein P is true and Q is false, the P implies Q is false. Let's have an example. Suppose that Jerby is a grade 11 student. Consider the following conditionals. Number 1, proposition P of 1 states that if Jerby is a grade 11 student, then he is a senior high school student. Number 2, proposition 2 states that if Jerby is a grade 11 student, then he is working as a lawyer. Let's have the solution. Number 1, the hypothesis and the conclusion are true. Thus, P sub 1 or the proposition 1 is true from the first row of the truth table for the conditional statement. While number 2, the hypothesis is true, the conclusion is false. Because grade 11 students is not qualified to be a lawyer. From the definition of the conditional, the second row of its truth table, the conditional statement of P or the proposition of 2 is not true. Let's proceed to biconditional proposition. Can you still follow? Okay, the biconditional of the proposition P and Q is denoted by with 2 arrowheads. Or P if and only if Q. And it is defined through its truth table. Let's have the truth table. The proposition may be written as P if and only if Q or P IFF Q. The propositions P and Q are the components of the biconditional. The biconditional statement is defined to be true whenever both parts have the same truth value. As you can see in the table, the first row wherein it consists of 2 true value for P and Q, therefore, the P biconditional of P and Q is true. And also on the last part of the table, which is for the proposition of P is false and the proposition of Q is also false, therefore, the biconditional of P and Q is true. The rest will be false. Let's have an example. Suppose that Jerby is a grade 11 student. Let us now consider the following biconditionals. Number 1, proposition 1 consists of or states that Jerby is a grade 11 student if and only if he is a senior high school student. Number 2, proposition 2, Jerby is in grade 11 if and only if he is working as a lawyer. Let's have the solution. Again, both simple components of P or proposition 1 are true. Therefore, the biconditional statement is true. Number 2, it is true that Jerby is in grade 11, but it is not true that he is working as a lawyer. Therefore, the biconditional is not true, referring to the second row of the truth table. Okay, grade 11 students, I think you get the topic. So let's summarize. Number 1, propositional logic largely involves studying logical connectives such as words, and or, and the rules determining the truth values of the propositions that are used to join, as well as what these rules mean for the validity of their arguments, and such logical relationships between statements as being consistent. Number 2, the conjunction of the statement P and Q is a statement P and Q, and it is denoted by this symbol. The statement P or the conjunction of P and Q is true when both P and Q are true. Number 3, The disjunction of the statement P and Q is the statement P or Q, and it's denoted by this symbol. The statement disjunction of P and Q is true when at least one of P or Q is true. Number 4, the negation of a statement of the statement P is a statement not P. It is denoted by this symbol. The negation of P is true only when P is false, and the negation of P is false when P is true. The implication or conditional is a statement if P, then Q, and it's denoted by P arrowed to Q. The statement P arrowed to Q is often read as P implies Q. And we have seen in the discussion that P implies Q is false only when P is true and Q is false. Number 6, biconditional statement is a combination of conditional statement and its converse written in the if-then form. A biconditional is true if and only if both conditions are true. Now, the floor is open to entertain the questions that you drop in our comment section. Okay, there's one question. The question goes like this. What do you think is the relationship between a propositional logic and mathematical reasoning? Okay, a very nice question. This will be the answer. The rules of mathematical logic specify methods of reasoning mathematical statement, while professional logic is concerned with the statement to which the truth value, true or false, can be assigned. Is there other question? I think we don't have other question. So this has been your live streaming teacher. I'm Mr. Setiel saying goodbye and God bless.